ASML of the Netherlands was once considered an invincible myth in the global chip industry. But today, in 2026, that myth is facing an unprecedented shock. While the U.S. Commerce Secretary is still anxiously investigating whether EUV components are flowing into China, a nationwide operation dubbed the Semiconductor Manhattan Project has officially launched in the East. This is no longer just a commercial competition. IT is a supreme showdown about national survival. China is firing three arrows at once, attempting to shatter the blockade that the West has painstakingly built for decades. Arrow 1. Reverse engineering. Former ASML experts have been assembled in Shenzhen to reconstruct an EUV prototype. Arrow 2. Blazing a new trail. Nanoimprint lithography, with a cost only 1/10 of traditional processes, is delivering a dimensionality-reducing strike. Arrow 3. Logic restructuring. Huawei is challenging physical limits with Tao's law and logic folding, aiming to run the equivalent of 1.4 nanometers performance on non-cutting-edge equipment. Is the blockade shackles, or is it the strongest catalyst for evolution? Today, let's look at how Taiwanese media are interpreting it. We are paying special attention to the simultaneous launch of the China-US tech war. The Chinese mainland has initiated its Manhattan Project. How? Through multiple approaches. They are bringing in former ASML engineers to advance the reverse engineering of ASML's EUV machines. At the same time, mainland China is building its own lithography systems, using its own technologies, including nanoimprint lithography, and also advancing DUV processes in parallel, directly dismantling ASML's monopoly system. Can it really be done? We will discuss these topics together. Point 3. Frontline topics. First, what does the mainland's Manhattan Project entail? It means reverse dismantling EUV. If that is happening, can ASML maintain its total dominance? Second, we see the mainland developing its own set of technologies that can completely bypass EUV. Can it really work? Technologies include nanoimprint lithography, DUV multi-patterning, and methods based on Tao's law. Third, if the U.S. keeps blocking ASML, but China creates its own alternatives, will the future chip supply chain split into two separate systems, two standards, two blocks led by China and the U.S.? These are the topics we care about today. ASML has now been pushed to the front line of the China-U.S. tech war. We received the latest reports from foreign media. The U.S. Commerce Secretary expressed high-level concerns to ASML executives, saying, "Your EUV extreme ultraviolet machines may have already flowed into mainland China. Such actions would violate U.S. export bans." Moreover, several unnamed U.S. officials even allege that ASML has not fully cooperated with American restrictions and has been involved in exports, secretly selling EUV-related components to China through a gray zone trade. Of course, ASML has flatly denied all these accusations. They even said it is impossible to sell to the mainland. Why? Think about how huge an EUV system is. The size of a yellow school bus. Moreover, global production volume is extremely small. And if they did sell one, it would require constant long-term on-site maintenance from the manufacturer. ASML claims it is impossible to have sold EUV equipment to mainland China. On the other hand, what makes Washington even more nervous, besides the incident we just mentioned, is that it sees mainland China continuously pushing forward its Manhattan Project, the Chinese version of the Semiconductor Manhattan Project. According to the latest Reuters exclusive, the mainland has recruited former ASML engineers to China and has selected Shenzhen as the location to reconstruct ASML's EUV prototype. Using reverse engineering, the plan is led by the Chinese government, with Huawei playing a key role, and has assembled 1,000 engineers to participate in the reverse engineering project. What does Hanting think? Can the mainland's Semiconductor Manhattan Project truly break ASML's monopoly? Reuters has once again pressed ASML, reflecting America's deep anxiety that ASML says they track every machine they produce and have not sold a single one to mainland China. But anonymous U.S. officials continue to accuse. We think you secretly sold to the mainland. Oh, they have evidence? No evidence. Oh, why does the mainland call it the Manhattan Project? Because building lithography machines is not pure commercial competition. It is a national survival-level engineering mobilization, just like when the U.S. poured all its national resources, gathering top physicists, engineers, and funds to create the atomic bomb. Today, whoever masters the EUV supply chain holds the entry ticket to next-generation AI, computing power, supercomputing, stealth fighters, radar chips, hypersonic missiles, everything. So of course the state must mobilize all its forces. The mainland's breakthrough now is not just about copying a machine or building one, but about cultivating an entire supply chain. That EUV is not simply a single device. It is a whole supply chain. Its irreplaceability does not lie in a single secret recipe, but because it integrates the craftsmanship of Germany, the US, France, Japan, and many other countries to complete it. Therefore, the mainland's current path demands that every single item be scored, every single exam paper be finished, every project be gradually completed. If we ask, can America's export controls hold the line? There are several layers. First, if the goal is just to stop EUV from being sold to mainland China now, that has been held because the Dutch government was pressured and even DUV sales are no longer allowed. So that is contained. But if America wants to ensure that mainland China never builds its own EUV, that is highly unlikely to be held. It is only a matter of time. Because while the blockade can indeed slow down the mainland's R&D, the blockade itself is also the best catalyst. From 2019 to today, the U.S. control list has grown longer and longer, and DUV was added. But mainland China never simply threw its hands up and said, "It's over, we quit." Instead, it pooled national resources to push forward together. Funds, research institutes, countless collaborators, hoping to break through from within. Third, the real battlefield has actually shifted. It is no longer only about hardware manufacturing, but about the entire logic of chip design and engineering thinking. From whether Moore's law has reached physical limits, to the emergence of Tao's law, or why DeepSeek could initially iterate through computing power and even slash costs. When physical limits are near, how can we change our thinking and even structural integration to achieve the same performance without the ultimate machine? On one hand, the U.S. is very afraid of ASML technology and equipment flowing into mainland China. On the other hand, the mainland says it does not necessarily need ASML equipment or reverse engineering. They believe they can now rely on their own technologies, take a completely different path, and build their own lithography machines. According to the latest South China Morning Post disclosure, the mainland plans to drive the Chinese semiconductor industry to jointly establish what they call a Chinese version of ASML. They openly call for casting aside illusions, prepare for struggle. With such a framework, we see various manufacturers developing their own solutions. First, as Hanting mentioned, Huawei is no longer following Moore's law but Tao's law, relying on logic folding technology. They claim that by 2031, they can design high-end chips with 1.4 nanometers equivalent performance. This will help Huawei launch its 9030 series with a massive upgrade. Kirin 9030. Next, another technology from another company. Nanoimprint lithography tools have already entered the production line. They do. Not Project Light. They directly imprint, without using DUV. And the key point. The per-chip cost is only 1/10 of traditional DUV. This is also something the U.S. worried about. Then there is Shenzhen's Xinkailai, which has also been in the news. They say their EUV exposure technology, combined with self-aligned quadruple patterning, can advance to 5 nanometers processes. What does generally think about China's current array of plans? I think the U.S. Commerce Secretary suddenly raising concerns about ASML, even suspecting that ASML may have sold the whole machine to China. Though ASML says they didn't sell the entire machine. But could they have pushed some very important key components to China? Why does the U.S. have this worry, this concern? I think it is closely related to Huawei recently launching its new mobile phone. The Mate 80 Maripolo Max. The chip it uses is the Kirin 9030 processor. Its performance originally was at N+2, meaning 7 nm, level performance that we know the Mate 60 was already 7 nm. Now it has moved one step further to N+3. What nanometer node exactly? We haven't got the correct answer yet. But I believe this chip is certainly more advanced than 7 nm, since Huawei has produced advanced chips below 7 nanometers. That naturally triggers the U.S. Commerce Secretary's concerns. Now we know that using ASML's original thinking to block China's chip development has forced China to find ways to overtake, that I think they are advancing on multiple fronts simultaneously. First is the Manhattan Project we just mentioned. Recruit retired ASML engineers, then use them to disassemble existing EUV machines. Study them step by step. That's the first approach. The second approach is nanoimprint lithography. Actually, nanoimprint is not a new technology. It was invented by a Chinese scientist in Japan back in 1995. And Japan's Canon already has this technology. It's not new. It simply bypasses the lithography machine. The IT doesn't use light. It uses imprinting. We know lithography uses light to photograph chip patterns. But imprinting can also work. Of course, imprinting has drawbacks. First, can you position every imprint with nanometer precision? If there is a slight error, yield could suffer dramatically. Second, after pressing many times, does the mold become blurred or inaccurate? Third, and I think most importantly, why didn't Canon continue to push it after developing it? Because switching to a new technology entails many risks you have to bear. That if you already have EUV lithography, do you really want to build a separate imprinting infrastructure? But now, since China is denied EUV, it must push forward and refine this imprint technology. I see this as one of China's breakout methods. The third method, DUV multi-patterning. It is like taking a photo. If you want to photograph a beauty, you take one shot, then enlarge it and take another shot, then enlarge again and take a third shot. The resolution matters, and in the end you can see what brand necklace she is wearing on her earrings. So chips can be made smaller. But this also affects yield, because like in photography, if your resolution is not high enough, yield may not be good. But it is another way to break through to I think China is seeking different pipelines, from imprint technology to DUV multi-patterning to the Manhattan Project. Even from theory, they improve with Tao's law, switching from Moore's law to Tao's law in various ways. They try to break through to SOEC mainland China, deploying many technologies to break through on a completely different path from ASML. On the other hand, everyone is also watching whether yields can keep up. That's the direction they are working on now. Then, General Zhang, how do you see the future? Will the US and China each go their own separate way? I think they will first go their separate ways, then split, and later integrate. It will definitely be two systems, just like we have GPS positioning and Beidou positioning. Which one do you choose? You could also demand both, correct each other, grab both together. That is integration. For now, theoretically, they split first, because mainland China has three major advantages. First, its products have a price advantage that we often hear about: cabbage prices, extremely cheap. Supply and demand determine price, and price also determines supply and demand. The cheaper the price, the more you sell. Expensive goods are rare and sell less. Mainland China has price advantage that we talk about overcapacity, which leads to cheap prices. Look at new energy vehicles, electric cars. Why are they sweeping the world? Because they are inexpensive. For the same price, the interior is better than yours. Consumers have freedom of choice. DJI drones. Why do they hold 70% of the global market? Because they are cheap. You, America, have a similar spec drone at 3 times the price of a DJI. You want it. You can buy 3 DJI drones for the price of 1 American drone. You save 2/3. Why wouldn't you save? Consumers will buy from an economic perspective. Second, mainland China has a market advantage. Africa has over 1.4 billion people. Southeast Asia has nearly 700 million. Together, that's over 2.1 billion. And India, 1.4 billion. Will it use American standards or Chinese standards? So far, not necessarily American. I see India making strategic adjustments. That's 1.5 billion people. Add them up, and the market emerges. The larger the market, the lower the unit cost, because you make more. Economies of scale. This market advantage, I think, is population advantage, which will gradually become prominent as more people gain consumption power. In the past, only nobles receive treatment. Now common people can buy too. Third advantage, ubiquity. Look at the Hungary-Serbia railway, 350 kilometers per hour. Indonesia's Jakarta-Bandung high-speed rail, 350 kilometers per hour, both built by China. China excels at railway engineering. Mainland China will have a ubiquity advantage in the future. I believe these 3 advantages will first lead to a split and later to integration. The direction of this chip war may just confirm that saying. Blockade is the best catalyst. While the West tries to choke China with old rules, China, in this Semiconductor Manhattan Project, is blazing new paths with nanoimprint lithography, logic folding, and other technologies, carving out a brand new road. The future global semiconductor landscape may no longer be a unilateral monopoly. Instead, like GPS and Beidou, it will move into an era of 2 systems and 2 sets of standards. 1 Chinese and 1 American. With extreme price advantages, enormous market scale, and full supply chain penetration, Chinese chips are breaking out of the blockade and emerging like a butterfly from a cocoon. This technological long march has only just begun. How long do you think it will take for the Chinese version of ASML to rise? Share your thoughts in the comments. See you in the next episode.